Hello. I wanted to make you a little extra video regarding the exercises for lesson 5.6. I had a couple students reach out to me regarding them, and they are tricky. I want you to, obviously getting the right answer would be great, but I want you just to kind of think about these graphs and what they look like and how you can use Desmos on like 36 and 38. So I'm not going to give it all away, but I'm going to show you a little bit here. So let's go up to 36 and 38. So 36, just looking at the shape of the graph, this is going to be a tangent graph. So we can go to Desmos here, and we can say, make a tangent of X graph. So we can see that 36 is right here. It goes up from left to right, and we've got our tangent graph. Now, this one here, it is 0 at 0, and then it looks like it's undefined at what would be pi over 2, because it'd be 4 pi over 8, and at a negative 4 pi over 8, which would be pi over 2. So if we look at what we know about tangent, and let's go to our Desmos calculator for a moment here. We can see the graph here of tangent. And if we look at our little table that we've been making, we can see that tangent is naturally 0 at 0, and it's 1 at pi over 4. So, and you can see that if you make go up to the gear and then make a table, you can see that let's just replace -2 with pi, and then -1 we'll do pi over 4, because that's where it's usually 1. Just some common ones. Okay, now let's go to the book. So the book, it's at 0 at 0, so that's a natural thing for pi or for tangent, and it's usually undefined at pi over 2. So let's just do a pi over 2 so we can see that. Okay, now back to the one in the book. It is at pi over 4, it is undefined. So we're trying to do something to this tangent function. So at pi over 4, it's undefined. Okay, and so we need it to be like 1/2 of that, maybe. We're trying to get that to be undefined at pi over 4. And we can also see that it looks about 2 at 3 pi over 8. And it looks like it might be 1 at pi over 2. So usually it's 1 at pi over 4. So if we want to get it to be 1 at pi over 2, I'm trying to get it to match what's on the book here. So it looks like it's 1 at pi over 4, and it's usually 1 at pi over 4. Okay. And then at pi over 2, it's usually undefined. So this is definitely stretching out a little bit. So we could say, what if we just doubled the tangent? So I'm going to put a 2 in front of the tangent. So at pi over 2, it's undefined. And it looks like it is going to be undefined at pi over 2. At pi over 4, it looks like it's 2. It doesn't quite look like it's 2 at pi over 4, though, right? It looks like it's 1 at pi over 4. So I want to do something inside my x. So what if I did 1/2 x? At pi over 2, it's 2. No, pi over 2 is undefined, so that's not going to work. Okay. Pi over 4, it's 2. That is true. Or pi over 4, it's only 1. Sorry about that. I had a phone call I had to take. And I want, without giving it away, I'm trying to help you see what I'm doing here. So at pi over 4, we want it to be about 1 from the graph, it looks like, and it looks like it's, okay. And we have pi over 4, it's 2. So we don't want that to be, let's take the tangent out. Okay, so pi over 4 is 1. Pi over 2, it's undefined. And pi, it's 0. And let's put in a negative pi over 2. Let's put in a negative pi over 4. So a negative pi over 4 would be a negative 1, usually. And this negative pi over 4, it is a negative 1. So this looks like the regular tangent function. So this goes up to pi over 2. And pi over 2. Let's do a negative 20 over 2. Okay. And let's do 2 pi. And 2 pi be 0. Okay. So the one I played with here, I played around with 2 times the tangent of 2/3 x. So mine is just about the same. Just about the same. It's off slightly. It doesn't quite turn as much. So that's where I want you to keep playing around with this to see if you can get it to try to match the picture. I don't want to give it away. Okay, I do want to, sorry. And then for the one with the cotangent, let's delete these. So the cotangent, so number 38 looks like it's going to be a cotangent the way it looks. And cotangent is 1 at pi over 4. And so this is actually much higher than pi over 4. This is sharper because this is, the picture is 0 at pi, but cotangent is actually 0 at pi over 2. So let's just put in cotangent of x so that we can see that. And let's just put in the table so we can put in like let's do 0 there. Let's do pi over 4. Let's do pi over 2. Let's do pi. Let's do 3 pi over 2. So we can just see what the regular cotangent looks like. Okay. Now, let's do one where we're modifying. Let's do another cotangent of x. Okay, so right here they're the same, but we want to modify, we want to try to modify to get ours to look like this one here. And so we want pi to be 0 to match our book. And at pi, it's undefined. So you know we're going to have to do some switching up there. Let's do 2 times the cotangent. And let's see what it does in the table. Actually, let's do it up here. 2. So we're using the same x values. Okay. So at pi over 4, and usually it's 1, and we at pi over 4, it looks like it's bigger than 2. So that's not going to work. And it looks like it's at pi over 2, it's bigger than 2 even. And so at pi it's 0. So we need to shift this. So what if we did 1/2 x there? Oops, okay. So at pi over 2, it's 2. At pi, it's 0. Okay, let's see if that, yep, at pi, it's 0. At pi over 2, it's 2. It actually looks like it's a little bit bigger than 2 at pi over 2, but let's see. Pi over 2, it's 2 and -2. Pi over 4, it's almost at 5. Does it look like that at pi over 4? Is it almost at 5? Yeah. So I think this is pretty close. 2 times the cotangent of 1/2 x is pretty close for 38. And then the other one that is the big question is number 46. So let's kind of focus and give you some pointers on 46. And on this, I really just want you to be able to show me your work and show me your thought process. And this would be like, I would not put one that's difficult on the exam at all. I want you to be able to kind of put things together. This is the end of chapter 5. So remember, we're kind of putting all the things that we've been learning in chapter 5 together. So we have this triangle. There's actually 2 triangles here. There's the RPQ triangle, and then there's the RPS triangle. Okay. So one thing that they said was unique is the segment P to Q. So P to Q is twice as long as R to Q. Okay. So that's going to tell us it's going to be a 30, 60, 90 triangle. And the length of segment PR is 45. Then it says, let D of X be the length of the segment PS, which would be the hypotenuse of the big triangle. Where X is the measure of the angle QPS. So this little angle here. So they want us to find A and C such that A is positive. C is between 0 and pi over 2. Okay. And they want it in this form here. A times the secant of X plus C. Now, instead of thinking like, oh, what could A be and what could C be? Let's just think about the definitions of secant, which is 1 over cosine, and how we solve for them if we know X or we know a side. Okay, how would we solve for the angle or whatnot? They also tell us use your function to determine the length of segment PS if x is equal to 2 pi over 15. Okay, so I'm going to show you the picture that I drew. And actually, I did a pretty good job for my. Okay, so here this started. This is S over here. This is P down here, and we know that this is 45 feet. And this angle here, they said, I'm just going to call this angle X is equal in radians to 2 pi over 15. Okay, so let's kind of, we want it in the form of secant. We know that secant of X is the same as 1 over cosine of X. Okay, and we also know that cosine of X is always the adjacent side over the hypotenuse, right? Okay. And so that means that secant would be 1 over the adjacent over the hypotenuse, which is the same as the hypotenuse over the adjacent. So we want to remember that. So if we look at the big triangle for this secant thing, then we're looking here. Where this is our right triangle. And this is the side that's in question. We want to know the length of that side. D, they define that as d of x, that function d of x. Okay, and so this is, since this is our hypotenuse, right? This is going to be our the angles that we're referencing is all over here. So this is going to be our adjacent. So if we thought of this secant x as the d of x, this, what we're trying to find, the length there is our hypotenuse over the 45 feet. Okay. So if we're going to solve for this length, we would say 45 times the secant of x is going to be equal to the length, the d of x. But they already told us that x, and we're talking this big X. So let's say secant of the big, we're just going to call this y. So the big Y is the big angle, right? And that angle is made up of X plus some C that they want us to figure out. It's going to be our d of x. So we have 45 times the secant of, well, we know x is 2 pi over 15. And we have to figure out c. So we know little x is 2 pi over 15. We have to figure out this little additional c here. This angle. Okay. So that angle C right here is part of this small triangle there. Okay. So we want to figure out what that is. Now I kind of gave it away because this is a special triangle where this side length here, let's call it B, is half of this hypotenuse of the yellow triangle, which is going to be 2B. So because it's a special triangle, that tells you something about the measure of angle C. So angle C is from the special triangle RPQ. So what you can do is you could, to find that angle, once you know, now that you know this is a special triangle, I don't want to give it away because it will tell you what the angle is. You need to find that angle. And then that angle is going to be your C, your addition down here in radians. And then you're going to use that to find out your length of the big hypotenuse on the orange triangle. So hopefully this has helped a little bit, getting you thinking. I want to see your work. I want to see what your thinking is, even if you don't quite get all the way there. Just giving it your best effort. And catch me back for another lesson.